Okay, so we've done our first little pad stacks here, and we've even done some footprints using the wizard. We are going to eventually move into custom footprints here, but before we do that, we should talk a little bit more about some of the important features of PCB board, which is actually redundant. PCB board would be printed circuit board, but anyway, there's a few other structures that we need to understand when creating layouts for PCBs. So let's look at some of those structures here. So let me pull up this image here. So the first structure that we need to also consider and create a pad stack for, but it's going to be a very different type of pad stack, is mounting holes. So we have a printed circuit board, and almost all printed circuit boards are going to be mounted in something. You're not going to have many that are just on like little posts and that are free floating around. The PC boards that are like kind of just on little rubber um, buttons or little rubber stands that you can kind of just move around are typically ones like Arduinos, for instance, like little hobbyist kinds of microprocessors and embedded controls. But if you think about most electronics, they're all going to be mounted somewhere. Like your cell phone has a board that's mounted in it. You know, your motherboards, you mount your motherboards in there. Now, the mounting holes, there's really two types of mounting holes. There's various sizes and dimensions and rules and things of that nature. The first type, which I'll kind of just have my mouse here circle, is what is considered an ungrounded mounting hole. Now, an ungrounded mounting hole literally means that it's not connected to the ground plane. And so there's no copper etch around it. It's literally just a drilled hole. And that can be useful, especially sometimes if you're using battery supplies or things of that nature, and you don't have to worry about short circuits or things of that nature. You can use some of those ungrounded mounting holes. And it really just depends on the circuit that you're laying out and designing. However, most mounting holes, and if you look at your PCB mounting holes, they would fall into these two categories here, which these are grounded mounting holes. Let's look at this one up here just because it's a little bit bigger and zoomed in. First off, you can see there's this copper plate that's exposed, and if you looked at the bottom side of the board, there might be another copper plate etch on it as well. But you can see this copper is exposed, and actually if you want to see here, this right here that I'm outlining with my mouse, that is actually all copper too. So that's all connected to this right here. So this is all actually ground right now because it's all connected into this hole. But then you can see it's also plated on the inside of the hole. And then there's these are called fiducials, or not fiducial, I'm sorry, these are called vias, V-I-A, and which is another structure we'll talk about in a second. And these basically go to make connections to different layers of the boards. And these are also plated. These are tiny holes that are plated inside as well. And so these holes then will go to typically the ground plane. These are typically more than one layer boards, or if they're not more than one layer, they have top and a bottom. And basically the idea is you have one layer of your board that's just um, literally just ground. And so it's just a lot of copper that's just ground. And there's reasons why you want to have a grounding plane. Again, beyond kind of the scope of this course at this point, but there's reasons you want to have a grounding plane. And so these vias will connect this copper pad to that ground plane. Okay, so that's good for us, but why do we have all these little vias here? Well, you're going to be putting in a bolt or some kind of screw or something of that nature. Probably, honestly, it's probably going to be a bolt like an M3 or something like that. Um, and when you put it in, you're most likely going to either have a washer that you're putting in first, or you're going to have the bolt that kind of has a wider flat disc anyway. And what this does is these holes basically make it so that it provides a better ability to have contact in case the screw was to start coming loose. So it makes it so that that bolt will maintain contact to the ground plane. And it's kind of just like, if you think about it, like you're wanting to have your connectors grounded. If you think about the way a car is even wired up, the frame of your car is is actually a ground plane for your car. If you talk about the battery in your car, the negative terminal of your car is grounded to the frame of your car. And again, there's reasons for that. It's kind of a similar idea here, except we're now using it on a much smaller circuit. We're using it on a much smaller device. Okay, so that's the mounting hole. Now, I mentioned another term called via, which we can see plenty of vias here. Via is basically just a connection to a different layer. Now, we are going to be doing multiple layer boards eventually here, in the sense that we'll at least do a top and bottom layer. And it might be, for instance, that on this particular one here that I'm highlighting, you can see these copper traces here. And like, for instance, this is a nice one. You can see this copper trace going off, and it's not going anywhere. It doesn't look like it's going to connect anything. But then there's this little hole, tiny hole with some copper around it, and it doesn't look like it's doing anything. It's just, what's the purpose of that hole? But that hole, it's a hole that goes to the other side of the board, or to an internal layer, but for us, we're just going to say two layers, so top and bottom. So it goes to the bottom side of the board, and it's plated. So basically, you're making a connection from the top side of the board to the bottom side of the board. And that means that you can then run whatever trace that this pin needs on the bottom side of the board, as opposed to the top. Now, again, there are reasons to do this. One reason can be the complexity of the layout, that you might just need to use multiple layers just to get everything connected. Another reason to use vias, again, is that you can connect to ground planes, power planes, etc. So a via is literally connecting one layer of a board to another. So for us, because we're only going to do two-sided or two-layer boards in this course, a via will be connecting the top side of the board to the bottom side of the board. But again, that's a structure we will have to define. Now, the last structure that we will have to define, and we're going to work on this week, is what are called fiducials. And so there's two fiducials here. Now, fiducials serve several purposes. For our etcher, fiducials serve a purpose for centering the board if you're having a top and a bottom etch, so that when you turn the board over to etch the other side, it uses the fiducials to recenter the board so it knows exactly the orientation, and it will make sure to accurately do your etches. Now, fiducials, though, are also used not just in the etch process of these boards, but also in the placement of components. So you can see there's all of these little pads here, and these leads are, very close together. As a board moves through an assembly process, there's the potential that maybe it's got jostled a tiny bit and it's not in a perfect alignment. And when I say perfect alignment, I'm not even talking about a lot of misalignment here, just the tiniest bit. But sometimes these pad stacks are so close together that if the component, because this is all done automatically, is placed slightly at an angle, well, you're going to have a pin that's going to be connecting on the component that will hit two of these pads, which is bad. And so what happens is there's a camera, and it sees these two fiducials, and then it knows, oh, I know exactly how to center myself now, so I can make sure to rotate the component and place it exactly where it needs to go, so we don't have to worry about the component not being exactly centered on the pads, the footprint that we've done here. And here's just another board showing kind of two fiducials, and that would be to center primarily this IC. Typically, like two terminal devices like the capacitors, it's not as critical for the fiducials, but for ICs, it's typically, we need some fiducials there. All right. So one last thing here to introduce us is, just like everything else in this course, we have a naming convention, and this is an IPC standard. We've already done this. So we've already done this in the sense of this very first one here, C150H90. So C denotes circular land with a 1.5 millimeter diameter, and hole denotes a size of 0.9 millimeters. Doesn't actually say the units here, but that's what that's doing here. Now V, well, we can kind of guess what that's going to be. It doesn't have it up here. It does tell you where V denotes a via, makes sense, 0.5 land, so 0.5 millimeter land, and a 0.25 millimeter hole, which is extremely tiny. And you need to be able to plate holes that are that small, which we can, that's more of a issue with producing the boards, which we won't really talk about. But if we scroll down here, we can see with the less use of V. V is used for vias. W, in addition to vias, W is what we use for mounting holes. And then there's some other things like non-plated hole, inner layer. So if we're looking at a via, by default, it's assuming it's a plated via. If you're wanting non-plated, you can see hole, non-plated hole. And this is, again, trying to show, giving you examples. So I would just read through this document. For instance, this one here, this VS stands for via, but the S denotes that instead of the default circle land, that the landing pattern is a square. And it still has a hole that, of course, the hole is going to be a circle because we're just using drill bits for these. And then there's a lot of other ones here. So the, V is a VX hole. And then this is saying on the opposite side of the board, there is a square pad. So there's lots of different things. There's chamfer, rounded corner modifiers. I mean, there's all sorts of different modifiers we could do. Here's for the rounded rectangle, which we've done before. And so there are lots of examples here on how to name our vias. So I will make sure if this is not uploaded, it should have already been uploaded to our Blackboard site, but if not, I'll make sure to upload it again. In fact, I'll make it just a directory instead of making sure that it's in the week, because then you don't have to go back and find which week. I will make a directory that contains our IPC standards for naming patterns, the 2 PDFs that we have that we're using in this course for naming conventions. Okay. And it says all alphabetical characters are lowercase as well. All right, so let's go ahead and wrap up for today here. And then the next set of videos this week will actually talk about creating these different types of holes, mounting holes, things of that nature.